So welcome everybody to this latest video on 162 Maths, and in this video we'll be going over an AQA GCSE Maths higher topic test around standard form. Now as always there'll be a copy of the test paper for you to download and have an attempt at either before or while watching this video by simply clicking on the link in the description below. Now before we get started working through this test paper, it's worth mentioning that there is no indication whether these questions are designed for a non-calculated paper or a calculated paper. So while working through this test, we'll just assume that it is all questions are going to be non-calculator, unless a calculation comes up where we'll have to use our calculator because it will just save up so much time. So let's have a look at question 1. So question 1 says, here are 5 numbers. Work out the difference between the largest and the smallest number. Give your answer in standard form. So it's really important that we do establish that this is what the question is asking, is to work out the difference between the largest and the smallest. Now from the options you can see we've got a sort of array of numbers written in ordinary form and in standard form. Now I personally would say it's worth just converting all the numbers into ordinary form. So this one's going to be 4 5 with 3 zeros, that's going to be 5 with 3 zeros, and this is going to be 2 8 with 4 zeros. So from this what we've got is this number here is our smallest and this one here is our largest. So working out the difference, I want to do 280,000 minus 5,000, in which the answer we should have is 275,000. Now what we want to do is write this in standard form, so that's going to be 2.75 times 10 to the power of 5. Then moving on to question 2, it says work out 5.9 times 10 to the power 7 divided by 2.3 times 10 to the power 4. Now I definitely would say that this is going to be a calculated paper. So working through this, I'm going to use my standard form button just to type it in. So it's going to be 7. And again, you could use brackets, but if you're using the standard form button, then that should be fine to do without. So divided by, but I'll use brackets anyway. So 2.3 to the power of 4. Close bracket, press equals, and you can see that our calculator has given it in ordinary form. So writing down the answer is we're going to have 2565.217. Now this to 2 sig fig is rounding this number up to the nearest 100. So it's going to be 2,600, and then we want to write this in standard form. So that's going to be 2.6 times 10 to the power of 3. So moving on to question 3, it says solve x over 0.02 equals 3.1 times 10 to the power of minus 4. Give your answer in standard form. So again, this will probably most likely be another calculated question. So here what we want to do is we want to get rid of this 0.02, and we do that by taking to the side and multiplying by 0.02. So x equals 3.1 times 10 to the power of minus 4 multiplied by 0.02, and if I type that all into my calculator, you should have an answer of 6.2 times 10 to the power of minus 6. And I would say that most calculators would already give your answer in standard form anyway, so it's just a case of just ripping off the numbers from your screen. Question 4 then says, in total, tourists visiting a country spent 5.2 times 10 to the power 8 pounds. On average, each tourist spent 645. How many tourists visited the country? Give your answer in standard form to an appropriate degree of accuracy. So looking at this, what we want to do is we want to do 5.2 times 10 to the power 8, as that's the total amount of money that they spent, divided by how much each of the people spent. So if I type that into my calculator, I get an answer of 806,201.5504. Now this is a number I then want to convert into standard form. Now there's a couple of ways in which you could write your answer, and it could be any of these. So it could be either 8.1 times 10 to the power of 5, or you could write it as 8 times 10 to the power of 6. Or you could write it as 8.06 times 10 to the power of 5, or 8.062 times 10 to the power of 5. Now personally speaking, I would probably opt for option number 1, simply because how they've written this number here is probably going to be the same format I would possibly choose. So as they've written it to one decimal place, I will probably opt for the same, but any of those 4 answers there would get you full marks. Moving on to question 5, it says here are the probabilities of two independent events. How many times more likely is event A than event B? So for this, to do that, what we've got to do is divide the probability of event A, and we divide that by the probability of event B. And if I type that into my calculator, I get an answer of 79.4, and they would accept any answer of 79 or 80 times more. For question 5b, it says work out the probability of only one of these events happening. So either you could have event A and not B, or we can have B and not A. Now, for this event to take place, what's that probability? Well, that's going to be 2.7 times 10 to the power of minus 2 multiplied by probability of not B, which is 1 minus 3.4 times 10 to the power of minus 4. Or means add. And then for this situation here, we want the probability of B, which is 3.4 times 10 to the power of minus 4, multiplied 1 minus the probability of event A, which is 2.7 times 10 to the power of minus 2. And if I type that all into my calculator, it's going to prove to be extremely messy. But if we do it separately, this blue bracket should equal 0.026998082 plus this pink bracket, which should equal 3.3082 times 10 to the power of minus 4. And if we add them all up, we get an answer of 0.027326164. And then if we just round that answer up, we get 0.0273, I would say, and that's to 4 decimal places. Moving on to question 6, it says that in the body, the ratio of the number of red blood cells to the total of all cells is the ratio of 5:9. It is estimated that there are 3.72 times 10 to the power 13 cells in total. Work out the number of red blood cells. Give your answer in standard form to an appropriate degree of accuracy. So in terms of the degree of accuracy, you can see that the number that's written in standard form has been given to 2 decimal places. So that's how I'm going to write down my final answer. So looking at this, what we've got is we've got 3.72 times 10 to the power of 13. Now this equals 9 parts. So then to work out the number of red blood cells, which is 5 parts, so therefore, if I do 3.72 times 10 to the power of 13 divided by 9 to work out what 1 part is, then multiply that by 5 to work out the red blood cells. And I type that all into my calculator, it should give me an answer of 2.07 times 10 to the power of 13.